Today I tell you about properties of fluids. So number first is density or mass density. Density or mass density. Number second, specific weight or weight density. Specific weight or weight density. Number third is specific volume. And number fourth is specific gravity. So I tell you about these one by one. So number first, density or mass density. Density or mass density. Okay, so now first I define it. So it is the ratio of mass of the fluid to its volume. Simple. It is defined as the ratio of the mass of of a fluid to its volume, to its volume. So from here we can define its formula. And one thing, we denote it or it is noted by rho. Okay, so rho is equal to mass of fluid by volume of fluid. Or we can define, so, and its SI unit is, its SI unit is kilogram per meter cube, because mass is calculated in kilogram and volume is in meter cube, because in when we find volume it have three sets. So when we multiply these three sets we find m into m into m is equal to m cube. So why through that we get it. So and the volume of density of water uh, is 1 gram per centimeter cube or 1000 kilogram per meter cube, or density of water is 1 gram per centimeter cube or 1000 kilogram per meter cube. And density of air at 20 degrees Celsius is 1.24 kilogram per meter cube. Now second, what is second point is specific weight or weight density. Weight density. So through its name we find that it is the ratio between the weight of the fluid or to its volume. So we can define it as it the ratio between the ratio between the weight of a fluid to its volume. Okay, so by that definition we also get its formula, and so it is noted by it's noted y w. Okay, so w is equal to weight of fluid, weight of fluid y volume of fluid. So from here we also write it as weight of fluid is equal to mass of fluid into acceleration due to gravity. Okay, means g. Acceleration due to gravity divided by volume of fluid. So it it's come as mass of fluid divided by volume of fluid into g, because g is the acceleration due to gravity, and it is it whole it is rho. So W is equal to rho c. Okay, so it is simple. And the weight density of water weight density of water is 9.81 into 10 to the power 3 Newton per meter cube. Newton per meter cube. Uh, After that, the next point is specific volume. Third point is specific volume. So what is specific volume? It is defined as the volume of fluid occupied by a unit of mass or volume per unit mass. So we can define it. It's defined as the volume of a fluid occupied by a unit mass. Simple. So we can simply now do it. We get formula from its definition. Volume of fluid occupied by unit mass. So it is a volume of fluid divided by mass of fluid. If in density we get mass of fluid by volume of fluid. So if we divide whole by 1, or we can do such like that, it mass of fluid divided by volume of fluid. It is normal when if you want you get from here to here, so it is equal to, it is what the same. So what is it? It is the density mass of fluid by volume of fluid. It is density, it is rho means. So and it expressed as meter cube per kg, and it is commonly applied to gases, and it is the reciprocal of mass density. simple. Reciprocal means which is divided by 1, so that is called reciprocal. And so now the next point is specific gravity. So what is specific gravity? Number point 4, specific gravity. Okay, so it is the ratio of the weight density of a fluid to the weight density of a standard fluid. Okay, it's the ratio of the weight density of a of a fluid to the weight density to the weight density when weight density is density, normal density, weight density of a standard fluid. So and it is denoted by, it's denoted y s, capital S. So remember it, we denoted as for specific gravity, not for specific volume. Okay, so capital S is equal to for, so S for liquid, weight density of liquid means density of liquid, y density of water. Here water is a standard fluid. So in every case when we find the specific gravity for any liquid, so we put standard fluid, water means we put water as a standard fluid, and for S for gas, so density of gas, density of gas divided by density of air. So for every gas, air is the standard fluid, so it is, so remember it for every time. Thus weight density of a liquid, thus density of a liquid is equal to S into density of water. Here we know the density of water, so it is 8 into 100 into 9.81 Newton per meter cube. Okay, and density of a gas is equal to S into density of air. So S into 1000 kilogram per meter cube. So if the specific gravity of a fluid is known, then the density of the fluid will be equal to the specific gravity of fluid multiplied by the density of water. For example, the specific gravity of mercury is 13.6. Hence the density of mercury, such that I write it uh, with different color. I write it here. Okay. So such as the specific gravity of mercury. Oh, okay. I write a whole this statement. Okay. I write whole this statement. So if the specific gravity of a liquid is known, if the specific gravity of a fluid is known, then the density of liquid, the density of fluid, then the density of fluid will be equal to, will be equal to specific gravity of fluid, specific gravity of fluid multiplied by the density of water, multiplied by the density of water, multiplied by the density of water. So we multiply with the density of water if the fluid, if the fluid is liquid, not gas. Okay. If it fluid is gas, then we multiplied by the density of air. Okay. So for example, I take one example. Okay. So it's simple. The specific gravity of mercury is 13.6. Is a specific gravity of mercury is equal to 13.6. Hence hence the density of mercury is simple. मतलब डेंसिटी, specific gravity of mercury is into 1000. So I get 13600 kilogram per meter cube. It is the density of mercury. Okay. So thanks, or please subscribe my channel. Thank you very much.